Hey again, guys. It is our last video of today, so we are going to look at a little bit of zero product property. We've done this before, so we're just going to see how this works when we have add multiply factoring and when we have special products. So just a reminder, when A and B are multiplied together and their product is 0, we said, like, if A is 2, what does B have to be? That was like 2 times B equals 0, and we said B absolutely has to be 0. And same thing on the other side. If A is not 0, or if A is not 2, so if A times negative 3 is equal to 0, then we said B absolutely has to be, So on the other side, if we have B equal to negative 3, A times negative 3 is 0, we know that A absolutely has to be 0. So if A times B is 0, either A is 0, B is 0, or both. So what we were looking at is make sure we know where the multiplication sign is, and then one of the two factors have to be 0 as long as our polynomial or our multiplication problem is equal to 0. So our 3 steps. Step 1 is going to be get it so that your polynomial equals 0. X squared plus bx plus c has to equal 0. Factor, or step 2 is factor that quadratic. We know add multiply right now and our special patterns. And then step 3, we are going to go ahead and solve by setting each one equal to 0. So let's look at number 1. The main thing I want to stress is you use solving when we have an equals 0. So if you look back at your notes, the last video we didn't have an equals 0, so all we did was factor and we were done. Here, if you have an equal sign in your problem, you will have an equal sign in your answer. So the first thing I'm going to do is factor with add multiply. Things that multiply to 4 are 1 and 4, 2 and 2, but I've got to add up to 5. So it looks like 1 and 4 is going to do it. 2 terms, an x and an x, a 4 and a 1. They both have to be positive, so I get positive 5. Please don't forget the equals 0. That is super important. Okay, now zero product property says my multiplication sign is here in the middle. Either what's before the equal sign has, or the multiplication sign has to equal 0, or what's after the equal sign has to equal 0. Okay, subtract 4 from both sides and x is negative 4. Subtract 1 from both sides and x is negative 1. So final answer is x equals either negative 1 or negative 4. And I don't care what order you write those in, that is your final answer. Okay, number 2, the first thing that I notice about this one is I don't have anything equal to 0. And that is my goal, to use the zero product property. So what I can actually do is I can say, let's just add 10 to both sides. I want that one side to equal 0. So now this side is going to be r squared minus 7r plus 10 equals 0. Notice I didn't combine any like terms because there weren't any like terms. But now I can factor using some add multiply again. Things that multiply to 10 are 1 and 10 and 2 and 5. I think 2 and 5 is going to be our answer, but we'll notice that we've got a negative 7, so let's make this a negative and a negative. Set up your two parentheses, equals 0. I need an r and an r, a negative 2, and a negative 5. So that's step 2 is factor. And then the last thing is solve. Multiplication's in the middle. So I need the r minus 2 equals 0, the r minus 5 equals 0, and I can solve each equation. So the first equation is going to be r equals 2, because I add 2 to both sides. Second equation is r equals 5. Final answer, r is either 2 or 5, and I'm all done. Okay, so again, first step, get it equal to 0. Second step, factor. Third step, solve. Number 3, this one, it's already set equal to 0. Thank you very much. Step 1, check. Step 2 is factor. Equals 0. This again looks like an add multiply. We can multiply to 3, add to 4. I think our only option is really a positive 1 and a positive 3. So I have a y and a y to get y squared. I have 3 and a 1 to get 3, and then a positive and a positive to add up to 4. Set each one equal to 0. The multiplication sign is in the middle. Y plus 3 equals 0. Y plus 1 equals 0. So if you can already jump and say, okay, that first equation is going to be y equals negative 3 if I subtract 3 on both sides. The second equation is going to be negative 1 if I subtract 1 on both sides. That is totally fine with me if this is all you finish with. Okay, we have x squared minus 2x plus 1 equals 0. Again, it's already equals 0, so solve or set it equal to 0's check. Then I factor. You could see that this was a perfect square trinomial, or we could add multiply. I don't really care which one you do. I've got a 1 and a 1 multiplying to 1, but then I need a negative 2, so I'm going to make them both negative. So I need an x and an x to get x squared, negative 1 and negative 1 to get a positive 1 for multiplying, and a negative 2. Each of these has to equal 0 if I do multiplication. So x minus 1 equals 0, and again x minus 1 equals 0. You will notice in this problem that our answer is going to be the same. If I add 1 to both sides, I'll get x equals 1. Same thing with that second equation. Add 1 to both sides and x is equal to 1. So in this case, all I'm going to say is that x equals 1, and that is my only possibility for an answer. And that is totally fine. It's just that my two answers were exactly the same. A little reminder on the right-hand side is that we're always looking at PEMDAS. So on number 2 specifically, to get r by itself, we had to add my 10 to both sides. Okay, there are several of these here. I'm going to leave 5, 6, and 7 for you to go ahead and try on your own. They look a lot like the last few. I'll put those up right at the end of this video, but I'm going to jump to number 8 because this one looks a little bit different. I know that I can always look for a GCF before I do anything. So in this case, my GCF is 3. So I'm going to take a 3 out, and I get 9x squared minus 1 is equal to 0. Okay. I still am going to have a hard time setting each of those terms equal to 0 because 9x minus 1, or 9x squared minus 1 equals 0 is still a little complicated. So I think this also looks like a difference of squares. Because if I set up two terms, 3 times 3 equals 9. X times x is x squared. And then a positive 1 and a negative 1 will give me that negative 1. Now I have multiplication signs in all 3 places. I can set each term equal to 0. I get 3 equals 0. 3x plus 1 equals 0, and 3x minus 1 equals 0. First and foremost, 3 can never equal 0. Get rid of that one. Doesn't really help us. But the other two, I can subtract 1 on both sides, and 3x is negative 1. Divide by 3 on both sides, and x is negative 1/3. Add 1 on both sides for that second or that last equation, and 3x is equal to 1. When I divide by 3 on both sides, x is 1/3. So my final answer, x is positive or negative 1/3. If you listed those each separately, that would be totally fine with me. I'm just saving myself some room and a little bit of pencil lead if I'm actually using a pencil by putting the plus or minus there together. So again, recap on that one. GCF first, then factor further. Number 9. Again, it looks like I can do some GCF before anything else. So our GCF is a 5. 5x squared minus 4 equals 0. because 5 times x squared is 5x squared, and 5 times negative 4 is negative 20. That equals 0 is, again, super important. Make sure you carry that equals 0 down. And then I can continue factoring. This is also a difference of squares. So the 5 stays, and my 2 parentheses will be an x and an x. To get to multiply to a 4, I'll need a positive 4 and a negative 4. Set each one equal to 0 because my multiplication signs are in those two places. Either 5 equals 0, x plus 4 equals 0, or x minus 4 is equal to 0. 5 equals 0 is never true, ever, so just get rid of it. X plus 4 equals 0, I can subtract 4 on both sides, and x is negative 4. Or I can add 4 on both sides, and x is positive 4. Final, I'll say that x is plus or minus 4. Again, the key things there, make sure it's set equal to 0, check. In this case, factoring meant a GCF and difference of squares, but then I set all of the terms equal to 0 to get my final answers. And number 10, our GCF here, because it's already set equal to 0, I can go straight to GCF, is 3. 3 times p squared is 3p squared. 3 times 5p is 15p. And 3 times 6 is 18. This one doesn't look like a difference of squares, but then I can check again for a perfect square trinomial. The 6 isn't a perfect square, so probably not a perfect square trinomial. And then I can always try and add multiply. I think this one will actually work. So I've either got a 6 and a 1, or a 2 and a 3. I've got to add up to 5. I think my option is 2 and 3. So I've got 3. My 2 parentheses, I've got to have a 2 and a 3. To add up to positive 5, I'll have a positive and a positive equaling 0. 3 equations. 3 equals 0, p plus 2 equals 0, or p plus 3 is equal to 0. 3 equals 0 is not true. Ever, ever, ever. But p plus 2 can equal 0 if p equals negative 2. P plus 3 can equal 0 if p equals negative 3. So those, again, are my 2 answers. Okay, so like I said, you guys can do 5, 6, and 7, and then you can check my work for your answers. Go ahead and pause the video because I'm only going to put like 5 seconds of space in between the two, and then you can, again, go ahead and check. Okay, so here are your last 3 answers. Number 5, this one we've seen come up a couple times. That polynomial is prime. We will learn how to solve that polynomial later, but right now if we can't factor it, we can't solve it, so we're going to leave it as is. And number 6, you can actually factor that one. We get a minus 7 and a minus 4 equals 0. If you set each equation equal to 0, your final answer will be a equals 4 or a equals 7. And then finally, number 7, we can factor that as well. It factors to m plus 8 and m minus 2 equals 0. So our 2 answers are m equals negative 8 and m equals 2. So that is our 0 product property when we have some factoring to do. And that is all for today. I will see you guys later.